There is absolutely no truth to the rumor that ATC will put you in an eternal holding pattern if you say bad things about the administrator. But as you know, they do occasionally put airplanes in temporary holding patterns when they have delays. Now, you already know how to set up a holding pattern at a nav aid, such as a VOR or NDB. But when ATC has to slow down the flow into a major terminal area, they often don't want the traffic arriving right on their doorstep and jamming up an already congested area. Nor do they want lots of airplanes tying up altitudes at a VOR used by multiple airways. Just think of the nightmare that could become. So ATC may ask you to do the aviation version of parking out in the boonies, and you may get assigned to hold at an intersection outside of the terminal area, just like the one you see here at Otis on the Cardi 3 arrival. Can I hear you saying, what's the big deal about holding at an intersection? Well, when you're holding at an intersection, you'll have to keep track of 2 nav aids instead of 1, and you won't have a nav aid to tell you when you're abeam of the fix to start timing your outbound leg. But one of the nice things about holding at an intersection is that you are very likely to already be on the inbound radial to the fix, and that makes the entry a whole lot easier. Let's say, for example, that you are southbound on Victor 186, and the controller tells you, clear to Robin intersection, hold north on Victor 186, left turns, expect further clearance at 1845, time now 1827. Now, Robin intersection is defined by the 336 radial from Pogge Vortac and the 083 radial from the Oceanside Vortac. Since you've already tuned and identified Pogge on the number 1 nav and set the number 1 OBS to 156 for Victor 186, half your work identifying Robin is done. All you have to do now is tune and identify the Oceanside Vortac on your number 2 nav radio and set your number 2 OBS for the 083 cross radial at Robin. When you're setting your number 2 OBS to identify an intersection cross radial, set it so that you're reading the radial from the VOR and not the course to. When you have the radial set and the from flag is showing, your needle will indicate the side the VOR is on as you approach the fix. Oceanside Vortac is to your right as you fly southbound to Robin, so the needle will point to the right as you're approaching the intersection. Then when the needle centers, you're there. If the needle were to the left on the side opposite the Oceanside VOR, you'd be past Robin. Now, your instructions were to hold north using left turns, and as you no doubt remember, left turns are non-standard. Since you are already established on the inbound leg when you reach Robin, you should already know the crosswind correction you'll need on the inbound leg. For the outbound leg, you'll double the correction you used on the inbound leg. Notice that the radials forming this intersection are not at a 90-degree angle to each other, so there's no easy way to tell when you are abeam the intersection on the outbound leg. How then do you know when to start timing the outbound leg? Well, it's pretty simple, really. Just start your time when your wings are level at the completion of the turn to the outbound leg. And just like holding at any other kind of fix, after timing your first inbound leg, you adjust the time on your outbound leg to try to make the inbound leg exactly 1 minute long. So now you know that holding at an intersection isn't difficult. But what if you're given an intersection hold and one of your nav radios has decided to quit? Or you're flying an older airplane that only has 1 nav radio installed. You can still identify the intersection with 1 VOR receiver, but you'll have a couple extra steps, so stick with me here. There are 2 keys to successfully holding at an intersection with only 1 VOR receiver. The first is to get established early when you're tracking the inbound course so that you'll know early on what heading will hold the course for you. You'll hold that heading to track the inbound leg while you're checking for the cross radial. The second key is to carefully retune, identify, and reset the OBS for the cross radial. Digitally tuned navs with flip-flop standby frequencies, like the ones in the new Skyhawk, make retuning easy, but you'll still have to check for the correct VOR ID. It's a good idea to keep the nav radio you're using selected on the audio panel. That way, you don't have to do anything else to make sure that you're tuned to the station you want. The first time you fly to the fix, you may need to switch back and forth a couple times before reaching it to confirm your position. Use your ETA to estimate when you're 1 to 2 miles out for a final switch to the cross-radial VOR. Since you fly a heading on the outbound leg instead of tracking a course, you can retune your VOR for the inbound leg after you're established outbound. That will give you plenty of time to make sure that you do it correctly. As soon as you're firmly reestablished on the inbound course, switch back to the cross radial and repeat the process. As you approach the fix each time, it's important to switch to the cross radial early enough not to miss it, but not so early that you drift off the course you're tracking. If you have a radio with a digital OBS like this new Skyhawk has, I'll share a trick that you can use in real life to make holding with one nav radio easier. Although I'll bet big bucks that you won't be allowed to use it on your flight test. The trick? Use the electronic CDI in the nav radio for one radial and the external VOR indicator for the other. That way you won't have to keep resetting the OBS. To find the electronic CDI on this radio, push the mode button on the nav side once. This is what you'll see. An OBS setting replaces the standby nav frequency readout, and a CDI with a V in the center appears underneath the active frequency and the OBS setting. A short deviation bar is the needle. To set the CDI, pull out the inner frequency setting knob on the nav side. You'll probably want to use the electronic CDI for the cross radial and the CDI on the instrument panel for the inbound leg course. That way, as you switch between VORs, the only thing you have to change is the flip-flop switch. Another way you can hold at an intersection is to select it as a waypoint in your GPS. And as you know, holding is one of those times you'll find the OBS mode of your GPS exceptionally useful. So, in addition to selecting the holding fix as your active waypoint, you'll need to select the OBS mode. Just select GPS for your #1 nav indicator and set your inbound course on the VOR indicator. Then fly the holding pattern just like you would using a VOR. However, with the GPS, you get the added benefit of constant distance information throughout the pattern. When you're flying toward the fix, the distance will count down. When it reaches 0, you'll know it's time to turn. Pretty neat, huh? ATC may also assign you to hold at a fix where DME is used to specify the length of the legs. If your holding instructions specify 5-mile legs, you'll start your inbound turn when your DME indicator tells you that you're 5 miles from the fix. If you have a DME or an IFR GPS, even if you're not assigned DME holding, you can ask the controller for permission to fly legs of a certain length instead of timing them. You can ask for any length you want. Airliners, for example, are often given 10-mile legs. The advantage of longer legs is, no, they don't make you run faster, but they do reduce your workload because they require fewer turns while you're holding. So, with several ways to hold at intersections and some new tools to do it with, you'll never be at a loss for a way to park and wait for a while, even if it's way out in the boonies.